All right. Well, it's about 6 o'clock, so I'll get started here in a second. Hey to everyone who's in the Zoom room. Thanks for joining, and I see people are also joining on YouTube, so you're welcome to join either. I'll probably have a closer eye on the Q&A feature in the Zoom link, but you're also welcome to ask questions on YouTube, and also keep an eye out on the hashtag AskRustExperts on Twitter. So feel free to ask any of your embedded Rust questions. I can also answer other Rust questions, but you're probably going to get the best answers out of me on embedded topics. Oh, wow. I think do me a favor and don't use the raise hands option. It's kind of kind of obnoxious for me. So do me a favor and don't use the raise hand feature, or I'll probably start booting people. But I appreciate everyone who showed up. I'll be answering questions for the next 2 hours or so. The recording for this will end up on YouTube like the last one. If you haven't gotten a chance to see the last one after this stream, maybe go check out the Ferrous Systems YouTube page. I posted the full 2 hours from last time. We had some really awesome questions about um, driver development and how to work your development flow and everything like that. So definitely check that out if you haven't had a chance yet. I'll also be probably sitting in the Rust embedded matrix room. I'll post a link up to that here in a second. But yeah, I'll probably be there because I'm generally always in there. But make sure to put your questions in on the Q&A feature, and I'll get started here in a minute once I'm done social mediaing everything. In preparation, I went and started a Twitter conversation yesterday, and it's had a lot of points. So if I don't get a lot of questions, I'll probably just end up going through some of the tweets that I got yesterday for things that folks are wondering about on. I phrased it as why aren't you using embedded Rust right now? And uh, people had opinions. So I managed to answer most of those. I still need to go back and answer all the ones that I didn't, but I got some really good feedback, and it was interesting to hear from a bunch of people that I don't usually talk to embedded about on Twitter. So that was really great. I'm gonna click Q&A, and it's probably gonna move it up here. Regular Zoom chat. Yeah. So yeah, I have disabled Zoom chat just because I didn't want to keep an eye on Q&A and chat at the same time. So if you have any questions, or if like last week I had my mic muted for like 2 minutes, if that happens again, feel free to just shove some Q&A questions in this that says, hey, your mic's muted. But yeah. Okay. Well, we got some people in the YouTube chat. We've got some people in the other, or in the we got people all over, so that's great. Okay, so I'll go ahead and get started. So we had a couple questions. I'll start with a Nabelgrau's question on Twitter because that's the first one I've seen. But yeah, well, let me give my quick little plug. So I'm doing this stream as part of Ferrous's Rust Experts plan. So we offer a service called Rust Experts where it's kind of exactly what it sounds. We help people who have questions but don't need it. So Fair Systems is a consulting and development house. We do a lot of Rust. We do a lot of embedded systems. We do a lot of embedded systems with Rust. We've got a pretty good group of folks who are pretty helpful, but not everyone needs like a full-time consultant, or they need help with a whole project. A lot of the times we have people who are just starting with Rust, and they just need some quick questions, like the ability to like, hey, I have this question. If someone had the answer, I'd be able to go right now, but I have to go look it up for like a half a day or a day to figure out the answer to some question or things like that. So Rust Experts is our service where you can hop in a chat with us. We can answer questions really quickly. And if you have a bigger question, like what library should I use, or what's the impact of doing this versus this, where you're not having us develop your software or doing reviews for your software or anything like that. It's an option for either individuals or companies who want help getting started with Rust. So kind of on-call support for any questions you have for Rust. So we're doing this Q&A series for the next couple weeks with a bunch of different topics. So my specialty is embedded systems, so I'm talking about mostly embedded systems today. I also know Alexei Kladov, who's the main author of Rust Analyzer, the IDE plugin for Rust. He's going to be doing a stream next week about answering questions about IDEs and workflows and tooling and things like that. So come back next week and he'll be doing one of these for that. And I think Florian's also going to be doing a talk. I'm not sure if he's picked a specific topic yet, but Florian knows all kinds of things from how to train Rust to general Rust development to async to community management and everything. So he'll be doing one, I think, the following week. And Jonas is also going to be doing one. I'm not sure what the ordering is, but he's going to be talking about, I think, the core and the standard libs in the Rust compiler, how to contribute to the Rust compiler, some of his workflows around that. He recently did some work to enable async await on bare metal programs and no standard platforms in general, including WASM. So definitely come and check him out when he does one of these as well, because he's got some awesome insights on that. So like I said, don't forget to post your questions on Twitter on the Q&A feature up here. Otherwise, I'm not going to have much. Well, I'll have a lot to talk about. But I'd rather answer your questions if there's anything you're struggling with or just wondering about, or how do I do this better, or things like that. So please do shove some questions in the Q&A or ask me on any of the platforms that I've talked about so far. And definitely check out Rust Experts. We're running a deal right now where normally it's 512 euros a month for individuals. Right now we're doing a 2-week sale where you can come and try out Rust Experts for 2 weeks for 64 euros. And it starts counting from when you ask your first question. So if you're interested in that, come join. It's kind of like this, but more on chat, but we'd probably hop on a Zoom call if you need something explained as well. So if this kind of question and answer is something that works for you and you're looking for continuous version of this, then definitely check out Rust Experts. And that's all on that for now. I've got a couple other things that I'm going to want to talk about later, but let's get to questions. So Nabelgrau is asking about cargo. So one Rust Experts question about cargo. Let's say I patch a library X and I define it in my TOML file as a local dependency. I also need library Y, which has X as a dependency. Do I also need to make a local version of Y that uses my local X to make a better example, and then has a bit of an example with embedded graphics and fonts and things like that? So typically in the development workflow, so I'm going to take these notes. I think last week I just put these up in a gist or something, but Rust Markdown, Rust Q&A. What's today's date? 2020-04-08. Cargo patch. So generally when you have a workflow, you have a couple. So if you're not super familiar with Rust, Rust has Cargo, which is a build system and package manager for this. And it works just as well for embedded systems as it does for desktop applications. So usually you're able to just use the libraries that exist out there, but occasionally, particularly in embedded, you end up needing to tweak things sometimes. If this is in your application or library or crate, then this is pretty straightforward. You just go in and edit it, and when you recompile, it's going to use that new version. Or if you need to make a modification to one of your direct dependencies, so I'll draw some, like, let's draw a dependency graph. You have, let's say, your app, and then you might have dep A, dependency B, and dependency C, and dependency A might depend on dependency D and dependency E. So like I said, if you're making changes to your application, you just make changes, and that's no problem. There's nothing to edit there. If you need to change one of your direct dependencies, what most people end up doing is you clone the repository down locally, where you maybe put it next to your project, and then you go into the cargo toml And let's say if you have a toml, and if this is your cargo.toml, you're probably going to have a section like dependencies, and you'll have something in there like dep a equals 0.4, and that's saying I want to use crate called dependency a at version 0.4. But if you need to make a modification to that, and let's go ahead and let's put all of them in there. So you only list your direct dependencies here. So you've got this, and this means that it's going to check them out from crates.io, and it's going to build them. But if you need to make a local change, you'll probably clone it next to your existing project. And you'll want to change that over from using the version on crates.io to using your local version, which has changes and things like that. So for that, you just use Cargo's syntax for dep a equals. So then you will instead specify like the path is dep a. So you say, okay, instead of using the crates.io version, I want you to use the local version. I think you can also do version equals 0.4 comma path. And this is Cargo is smart enough to say, okay, when I'm working locally, use the path version, but when I publish this crate online, use the published version of version 0.4. So you definitely can do that. Let me check Q&A just to make sure that someone's not telling me my mic is muted. Okay, cool. Actually, a question. So I will get to that in a minute. But the problem is if you have something deeper in your dependency, where you either have dep D, or even if you have something like dep B also depends on dep A. If you need to change that, if you change it here at the top level, this one's going to be using the path dependency, which is great. But this one isn't, because you haven't edited it kind of like recursively. This one's still using the published version, which is not great, because also sometimes if you make some significant changes, these two aren't even going to play well with each other anymore, which means you might run into some issues there. The way you do this is there's the cargo patch syntax. I'm going to pull up the docs for cargo patch. So if you search like cargo patch or cargo manifest syntax, you get this, which is like all of the different pieces of syntax you can use in a cargo toml manifest. So these are called package manifests or cargo manifests. These are those cargo.toml files you see in all of the projects. But the one that we care about here is called patch. And what this does is it not only changes the one at the top level, it changes it everywhere it appears in your dependency graph. So you change this one and this one. So instead of using this syntax, you don't even actually, you don't even actually need to comment this out. Let's comment this out. But instead, you're going to add this section for patch. So you would do something like patch.crates-io. And this says for any crate that I've gotten from crates.io. And this syntax is there because technically it's possible to get crates from multiple sources, but most people are just pulling them from crates.io. So you would say patch crates.io, and you would say dep a equals path equals / dep a. And this says everywhere that dep a appears in my dependency graph, replace that, which means not only will it be replaced here, it's also replaced here, which is what you sometimes need if you're using a library that like shows up in multiple places. If it's like a really fundamental trait or a just a commonly used library or something like that where you're using it at multiple levels, you'll probably want to replace the entire thing. I think the example that NableGrad was using was with embedded graphics. Yeah, so there's the embedded graphics crate, which is used as kind of a, let me show you, because Rust embedded graphics is a super cool thing. It's kind of an abstraction layer for, not that. It's an abstraction layer for building UIs on displays in embedded systems. So you can build all kinds of things from like images to dynamic things like clocks or text and things like that. It's a super useful high-level API and includes support for just a ton of different displays already, and it's fairly straightforward to implement support for new displays. So people use this all the time, but if you're using embedded graphics at the top level, but also some other library you're using is also using embedded graphics, you need to replace the dependency all the way down the chain if you're making some kind of fundamental change to embedded graphics. So you'll want to do that with the cargo patch syntax. So let me put a link to this so I remember how to go and find this later. Important link. It's there. So definitely use that. Yeah, you use this in embedded a bunch, particularly if you're touching libraries that you're adding functionality for. So yeah, this is one of those things. I never remember the syntax. I always have to go Google the reference for this. Maybe at some point I'll remember it, but it got asked last week and it got asked again. So it's definitely something that is a useful part of your workflow that comes up fairly often. Okay, cool. So thank you, Neighbor. Hopefully that answers your question. If not, ping me and I'll answer it further. So Pablo is asking, "Hi James, I'm a big fan of Rust since some years. I have a project for ESP32 with the Arduino IDE. Do you think it's worth using Rust with the ESP32? Would it be hard to enter?" So Rust and Rust Embedded have support for a couple different platforms. So let's talk about ESP, Arduino, and AVR. And this actually came up a bunch on that Twitter conversation I was talking about yesterday, where that was one of the questions I got asked the most is I said, why aren't you using Rust on your embedded systems today? And some people were saying, well, there's no support for AVR, there's no support for ESP32. So in general, Rust is built on top of, Rust is the compiler that you use for your syntax and things like that. Rust is built on top of the LLVM project, which is a common compiler backend. It's used by Clang for C and C++. It's used by Swift. I think it's used by Zig for the Zig language. It's used by a bunch of different languages because it's a really nice framework for building compiler backends, and it provides a lot of benefits like it's a lot of benefits because it has like really awesome optimization passes. It supports a lot of targets and things like that. So it makes it very easy for language builders to support a lot of platforms and have pretty performant compiled languages. The downside to it is LLVM doesn't support every platform under the sun. Typically LLVM is it tends to follow the most popular architecture. So it's definitely an open source project. So it's kind of down to the people who are willing to contribute to it. But it's kind of harder to support legacy or niche platforms some of the times. So in general, Rust is more or less today limited by the platforms that LLVM supports. So historically, even though AVR has been around for a while, it's an 8-bit target with 16-bit pointers, and also it's the Harvard architecture. So it works a little bit differently than a lot of other platforms like x86 or ARM. Additionally, AVR's had pretty good GCC support for a while, so not as many people were pushing for LLVM support. However, in the recent years, that has changed. There's been an AVR branch of LLVM, and for a couple of years, there's also been a Rust AVR. So there's a project called AVR Rust that's maintained by a couple people in the Rust ecosystem, and they've been keeping the Rust compiler front end in sync with the version of the fork of LLVM that does support AVR. So you can actually use Rust on the AVR platform. But it means that you need to not use the mainline Rust compiler, but instead use this fork. The story for ESP32 or even ESP8266, the Extensa architecture is very similar. There's the Rust Extensa Quick Start repo, where this is a very similar, let me put these links in here so I don't forget. Basically, people are adding support for these platforms in LLVM, which means Rust very quickly, once LLVM does support them, Rust can add support for them. I'd say the AVR one has been much more hobbyist driven, but I think in the last couple of months, people have been talking about it's on track to be merged. So I would say that it's likely in the next couple months we could see a version of like an official version of Rust that does have support for AVR. The Extensa, so the ESP32 and the ESP8266 platform, Expressive Systems is working on an LLVM port, so it's a work in progress. There's progress being made, and this repo, basically these two repos are, the answer is you have to use a fork of Rust that uses the version of LLVMs that supports these targets. That can be somewhat painful to build yourself. These two projects are making it easier to do that. Extensa, I believe, provides Docker containers, which have this environment kind of all inside of it, so you can do things more directly. And AVR is doing something fairly similar, where they provide instructions on how to build it yourself. So where those two platforms are right now is you still have to build the compiler from scratch yourself, which is way, way, way more work than on ARM or RISC-V or MSP430, where there's already support in the main Rust compiler. So your question is, do you think it's worth using Rust with an ESP32? I think that sort of depends. The answer is maybe. I definitely say it's worth trying out. Like if you have some time and you'd be interested in trying and getting a Blinky Lights, or I know both of these repos have some examples of, I think they link to it in their repos of some existing projects and some people who have already started building some larger applications on both of these platforms. Check it out. I don't know if I can necessarily, like, wearing my like consultant hat, I don't know if I'd recommend it for a commercial project, but both of these kind of side projects are making progress. If it's something that's important to you, either the ESP32 or the AVR platforms, and you can contribute, then I think they'd probably be happy to have your help. Or if you're a company and you're interested in making this happen, talk to Ferrous. We'd be happy to talk to you. But I'd say it's worth trying out. I don't know if it's necessarily worth making the big jump. I'd probably recommend, if you do want to try embedded Rust, to choose one of the more supported platforms, at least to start out. So there's a ton of ARM boards. There's RISC-V boards that are well supported. There's also some MSP430 boards that are well supported by some folks in the embedded working group. So I'm hopeful for both of these architectures. I don't know if I'd recommend it for production right now, but I'd probably recommend you check it out. Hopefully that was a vague enough answer to your question. You also mentioned the Arduino IDE. So the Arduino IDE is really interesting because it's kind of an all-in-one package for building these applications. You get an IDE, you get driver support and things like that. They have their own package manager. If you haven't had a chance to check out embedded Rust, I would definitely check that out. There is a very similar, all-in-one approach from the Rust side of things, in that you just use the Rust compiler, the same Rust compiler you would use for the desktop, and it has support for embedded built in. So if you're interested on how to get started with that, there's the embedded Rust bookshelf is something you can search, and you can pull up our docs page where we give all kinds of guides on how to get started. So the embedded Rust book assumes that you know Rust and you know embedded, and you want to learn how to do embedded Rust. There's also the discovery book, which assumes you know Rust, but doesn't assume that you know embedded, and will actually walk you through some basic embedded concepts. And both of them talk about how to set up your command line. The nice thing about embedded Rust is the same IDEs that work for desktop Rust will also work for embedded Rust. So you can use VS Code. You can use things like the Rust Analyzer tool, which gives you syntax highlighting and stuff like that. And I know there are also a Cortex-M debug plugin and other plugins like that, which will help you get debugging right in your editor. So there's also kind of it's still a little build it yourself of all the components are there and they're well integrated, but it's not like the Arduino IDE where you just get like one window where everything's self-contained. So yeah, like I said, I definitely suggest checking it out. If you're looking for kind of the easiest path, we have the most documentation for ARM-based platforms, so I'd probably suggest checking it out there. And if you do want to go back to ESP, there are options. In a couple months, it might be a first-class citizen. If not, then there's definitely good guides on how to get started. So I definitely wanted to answer that one a little bit more in detail because that came up a lot on Twitter. So hopefully that answered your question. I know there's not a definitive answer, but I'd probably say check it out. It's up to you to decide how much time you have and how deep you're willing to dig. But if you run into any problems getting either of those working, definitely open up an issue and the folks in the chat, or just ping me, and I'd be happy to help see if I can get you started. Okay, so that was that question. Let me clear out some of the thanks. Sometimes, yeah, no problem. Bob was saying thanks, so no problem. So Hazel UTF is saying sometimes it is useful to have an example work on multiple targets or boards. I'm not totally sure what you're referring to, whether you were part of one of my earlier questions. Let's see. Oh, you have a follow-up question. What is the best way to structure a Hello World blink such that different pins for different boards can be specified separately from the main code? For example, I assume how Arduino does its pin peripheral naming would not be great. So Arduino uses, like, to make things abstract, they just say, okay, we're just going to number everything. So you have got like digital pins, which might be like pin 1, 2, 3, 4, 5. Or you might have like analog, their digital input, output, analog input, output, you know, A1, A2, A3. This is really nice because you can have top level examples that look exactly the same, and you can run them on different pieces of hardware, which is actually super convenient, particularly for people who aren't super familiar for embedded systems things, like, or even just like they've only worked with one platform before. So all these vendors like Nordic and ST and things like that all have like subtly different process and naming and components of their like just even naming schemes. So giving them like a consistent name like 1, 2, 3 is useful from the Arduino perspective. So we do things a little different in Rust. So to answer your question, I'm not sure if I have a great answer of how to do that exactly the way the Arduino system works, because I mean it's a solution that's pretty specific to how Arduino decides to do that. For portability story in Rust, instead we're using Rust traits. So Rust has these things called traits, which are kind of like interfaces where you can specify what the interface is separate from the thing that implements it or the thing that consumes it. So let me talk about embedded HAL a bit. So we use Rust traits for interfaces. And then we kind of split things into 3 parts. You've got the, in the middle actually, you've got the traits or interfaces. Below that, you have the thing that implements the trait. And above that, you have the thing that consumes the trait. So what do I mean kind of more concretely about this? So embedded HAL is really just a collection of these traits. There's actually not much more in it other than these trait definitions. But if I go look at like a really simple one, like blocking serial, why does this only have write? Where's blocking read? I'm probably looking at the wrong thing, but let's go look at SPI instead. What am I looking at? Where are all the, oh, right, they're probably just using the read traits. Let's go even simpler. So you might have something abstracted like an input pin, where you just say this is an interface for how to read from an input pin. So what can you do with an input pin? You can check if it is high or if it is low. Similarly, if you have an output pin, what can you do with it? You can set it low or set it high. This means that you can do something like have just the trait, which says it's an input pin, is low, is high. You can have the thing that implements the trait would be like the specific platform driver. So if you have like a Nordic NRF52 or an STM32 or something like that, you'd say, okay, for this board, pin A4 is going to implement the input pin trait, which means given pin A4, I can check if it's low or if it's high. So this might be your like NRF52, and the HAL is where we would put this. And the thing that consumes that trait might be something like a higher level driver. Like you might write a driver for like debouncing an input or something like that, where it just checks the input, every 25 milliseconds or something like that. And if it looks for, so I'm going to put debounce library, where it looks at like the GPIO like every 25 milliseconds, and then if it's high or low for enough milliseconds, then it says, yes, this was a good button press and not just like an error or something like that. And this is really nice because you can write libraries that consume any GPIO from any manufacturer, and you can have any driver, like a hardware abstraction layer, that works with any platform. And because you use kind of this trait as the middle ground, it works really well. So the debouncing is an example for like GPIOs, but you could have like a GPS receiver that just sends data over a UART or something like that, where you could have the implementation of a UART or a serial port at the NRF52 level. And you could have just the trait that says, this is a serial port. How do I read from it? How do I write from it? And you have the things that consumes that trait, like a GPS parser. Like you might parse like the GPS messages that are coming in over the serial port and just process those. But when you write the GPS library, you don't want to say, here's my Nordic GPS library and here's my ST GPS library. You just want a GPS library that works everywhere. So we use these interfaces super abstractly. The thing where this falls apart a little bit, text is not much reasonable, but there doesn't seem to be setting for that in Zoom. If text is not great, let me know. Otherwise, Nabelgrau, I'm not sure if you have a lower res input. Let me stop the share and let me share my screen again and make sure I click the high def button. Yep, I've definitely clicked the high def button. So this is the best. If it's not working for you, maybe check out YouTube. YouTube might have a higher version of there, and I'll try and keep my font size as large as possible. But to answer your question, hello worlds are the hardest examples to optimize for, because you want to make sure that you are building, like, these embedded HAL traits work really well for like full applications. But when you have a hello world, you spend all of your time doing the setup stuff just to do nothing, basically. So what this usually looks like, Otterpill. Let me go pull up a project that I've done recently. Oh, now I'm sharing the wrong screen, I bet. Stop share. Everyone got to see the Q&A preview. Okay, so now I'm sharing the right screen. But yeah, this is a project that I did where I just have a little embedded system that talks over USB, and it was really great because I was able to write a driver that worked for an I2C device. So this was using the Adafruit Neo Trellis on it, but it uses I2C. But essentially, you end up, wow, this is actually probably a wrong example because there's a lot going on here. But like the setup is going to be pretty specific to the platform that you're on. So like this is my setup code where I do stuff like set up the GPIOs, set up the I2C, set up the USB connection, all these kind of things, where this stuff almost always is really, really board specific. In embedded Rust, because we don't want to make any assumptions on what you're doing. So Arduino might just give you some configuration that works, or a selection of like, do you want it at 24, 48, or 96 megahertz? And those are the only configuration options you have. In Rust, you might want to configure things down to whatever level of configurability that exists there. So yeah, I'm kind of going off the rails here, but setup in Rust is usually pretty specific to the board that you're on. So it's hard to write examples that work on any platform. Or what you'd want to do is you'd want to have a separate file that was like, okay, here's not main, but here's like the next function, where you hand me an embedded HAL GPIO, an embedded HAL UART or something like that. And that's going to look exactly the same on every platform you're running on. And otherwise, the setup's going to be a little different, because how you set up an STM32 is totally different than how you set up an NRF52, if that makes sense. So you're saying, so would it be better to have a separate examples target name, or is there a way to have files only with conditional includes let underscore MCU model perif. I'm not sure I'm totally following what you're asking, but usually when you have a driver for, let's find Rust SSD 1306 crate. So what most people do, what most people do for, let me go find on GitHub, because I know this has good examples. Usually for like examples, they'll pick one platform or they'll have a couple different examples for a couple different platforms, but usually they'll just pull in one board and things like that. So yeah, I mean, if you have separate examples target name, that would totally work, where you say like, I was hoping this one had one, but I've seen one where it's like STM32F0 hello, or STM, those kind of things. So in general, you can do all those kind of things, but there's probably not, we haven't generally optimized for like the Arduino, here's exactly one snippet of code that will run exactly the same on multiple platforms, but rather once you've done the setup, all of my business logic can run on all of those platforms. So hopefully that answers your question. If not, then feel free to ping me, or I'll come back around to that and see if I can clarify more on that. But in general, there's not like the Arduino style, you can just run this snippet on all of them, just because we do expose all of the low-level configuration options. I'd be really interested to see if someone made a higher level version of that, where it's just, we'll just set it up and it will work. But I have a feeling that a lot of the Rust people would want to get down and change things specifically. So hopefully that answered your question. Otherwise, feel free to ask follow-up questions if I missed something, or shoot me a message somewhere. So let me clear out some questions. Yeah, otherwise, yeah, if I don't get a chance to come back around to this, feel free to ping me on the Matrix chat or ping me on Twitter or something like that. And I'm happy to chat more, or yeah, we can find the answer to your questions. Give me 1 second. Okay, I'm gonna go peek at some of the other chats and see if there are questions coming in. Nabelgra, I have seen your other question. Let me just see if anyone else has a first question before I come back to your second question. Yeah, it's cool to see how embedded versus, it's so cool how embedded versus desktop Rust works. I have two IDE windows, and one of which is my server and the other is embedded stuff. There's no real difference. Yeah, that's definitely one of the things that I appreciate, is that like all the tooling and stuff works exactly the same. Typically, the only thing you need extra for the hardware is to be running like a GDB server or something like that, somewhere to just like talk to your hardware for you. But once you've done that, it's even possible to run like cargo run from the command line and have that automatically flash your device. So definitely I agree with, I'm reading some YouTube comments now, where they're saying, yeah, I definitely agree. So someone else is asking, do we need real hardware or can we run on an emulator? So I definitely know people have gotten stuff running on QEMU or QEMU, QEMU, QMO. I never know. This is one of those things I read all the time, but never talk to people in real life about. But I definitely know that there have been Rust projects that do work on QEMU. Excuse me. So it's definitely possible to use that. How far you can get with the emulator is somewhat limited, because a lot of times QEMU does a good job of emulating the CPU, but not necessarily the peripherals. So you certainly can practice embedded Rust there, but most of what embedded systems, in my experience, is interacting with the real world and other systems that are connected to your microcontroller. So you certainly can use QEMU, but you will probably run into the edge of what is like, it's probably not going to feel very different than running on a desktop, because you're going to be doing things like writing functions or libraries and things like that that run in a self-contained software world. If there are other emulation platforms that I'm not aware of, basically if you can run a Cortex M binary on those platforms and you can just give them an ELF and run them in an emulator, you definitely can run Rust on those. But I'm not aware of too many emulation platforms, particularly open source ones. So we use Kimu for some testing, just for sanity checking of some things, but I think you'll run into limitations there. However, there are a lot of boards that cost like you'll see them mentioned all the time. There's like the Blue Pill board, which is like an STM32F103. You can get a board and a debugger from like AliExpress or eBay for like under $5 or $6, or even STM offers some of their Nucleo boards that have a debugger and a main microcontroller, and sometimes even LEDs and buttons and stuff like that on that for well under $10 or euros. I know not all places in the world you can ship them, but um, most places you should be able to order from DigiKey or Mouser or Avnet or any of those other suppliers. So there's definitely a lot of low cost ways to get involved with hardware as well. And most of those are going to be pretty well supported by Rust. So if you're wondering what board should I get, the awesome embedded Rust list is something that the embedded working group maintains. And it's basically just a big list of cool stuff. So like the table of contents is this long, but it goes over all kinds of like learning resources and tools. And then it gets down to like different manufacturers of what kind of libraries exist, both like the low level pack or peripheral access crates. So like these are really low register level interfaces. And then you've got the higher level HAL implementation crates. This is where you get to the point where you're saying, I'm talking to a serial port and I just want to send bytes over a serial port, where like the pack is, I want to shove this byte at this memory address. The HAL is, I want to send these 27 bytes over a UART. So you can see like which ones are there. You could take a peek at how well they are supported. I will say like the STM family is probably one of the most widely used across most of embedded, I would, in my experience, but also in Rust, there's fairly consistent support for the STM family of chips. So if you're looking for somewhere to start, that's probably not a bad place to start, because there's just a lot of resources for those already. But yeah, you definitely can start in an emulator if you just want to take a test spin before buying anything. Definitely try that out. There's just embedded Kimu. I know Japarek has specific support for, yeah, oh, that's right. Even in our book, we have a whole chapter of how to get started with the LM3S6965, which is a simulated Cortex M3 microcontroller. So this talks about how to get it set up, how to get attached to it, how to cross compile for it. So definitely check this out if you're interested in emulation. So Adele on YouTube is asking, does embedded systems include systems like iOS or Android? Will Rust support it in the near future like Flutterway? Appreciate it and thanks. So I'll admit I don't do a lot of mobile development, iOS or Android. I know certainly Rust does. I know people using Rust in production on iOS and Android platforms. So that's definitely possible. Probably just because my knowledge of it is super not deep. I probably won't go too deep into it, but there's definitely it's not really handled by the embedded working group. So that's not going to, you're probably not going to see us talking about that there. Sometimes we do help because we end up talking about cross compilation and tools that you need for that, but we don't. But I know there's a lot of blogs and things like that for how to get Rust working on Android, how to get Rust working on iOS. I know at Ferrous, I've advised some clients on how to get that up and going and pointed them towards resources when they've had questions about that. I know there's some tricks around iOS where it's important to be using the same version of LVM that Xcode is using, just because otherwise things won't work well. I think that's more specifically for like Apple Watch and stuff like that. So the answer is you totally can do it. I'm not familiar with Flutter. I think you mentioned it. Was it Flutter or Dart? Flutter. Okay. So I'm not super familiar with Flutter, so I'm probably the wrong person to ask, unfortunately, but there's definitely resources out there. And like I said, I know people shipping Rust as part of their application, as well as shipping full applications written in at least primarily Rust outside of the UI layer. So it's definitely possible. You can do it today. Yeah, but like I said, I'm probably not the right. I do a lot of more bare metal and embedded Linux stuff, so unfortunately, I'm probably not the right person to ask about that. But good luck with it, and if you run into any problems, feel free to reach out, and I'm happy to help find someone who can help you. So feel free to always at me on Twitter or something like that if you run into any issues. Okay, I think that catches me up on YouTube. I see Nabel Grouse second question is still in Q&A. I'm also going to pull up burp, burp, burp. Okay. Well, then I'm going to take a quick break and stand up, and I'll be back in like 2 or 3 minutes to come back and answer some more questions. If you have questions or if you've thought of them now, please do put them in YouTube on the Zoom Q&A or with the Ask Rust Experts hashtag on Twitter, and I will come back and check it out. And otherwise, I'm just going to stand up, stretch, and drink some water and be back in 2 or 3 minutes. All right, thanks. Okay. I saw a couple more questions come in while I was gone. Let me answer a couple quick ones. So someone in YouTube is asking for embedded in Rust for beginners. So I mentioned it before, but I'll definitely plug it again. Definitely check out docs.rustembedded.org. Beginner resources. Definitely check out docs.rustembedded.org. That's where we have all of our resources, or the embedded working group who's working on from the Rust project on embedded systems. So definitely check that out. We've got the discovery book, which is great for people who are beginners in embedded development. So generally, if you haven't used Rust yet, I would definitely check out the Rust book. So the Rust project maintains a book called The Rust Programming Language. This is available online totally completely. And there's also a print version of it. I'd highly recommend it. There's also a bunch of other books that have been published, like the O'Reilly book and some other ones, depending on what your learning style is. There's also Rustlings, which is a bunch of small exercises, which are awesome for getting used to Rust code. The nice thing about Rust is that the skills you learn on the desktop will transfer to embedded. It's not like two totally different worlds. There's certainly some different things that you need to know in the embedded domain, but any effort you put into learning Rust as a language will definitely transfer over. And I'll talk a little bit more about that if there aren't specific questions. But let me add a note to myself. Let me just add a note about no standard, because I also saw that mentioned in the chat. But definitely spend some time learning desktop Rust first, just because I feel like there's less to overcome. You don't have to worry about how to set up your hardware or anything yet. So definitely get like a little comfortable with Rust as a programming language before you start with embedded Rust. Even if you are already an embedded developer, just a couple days, check it out, do some of the exercises until it feels like normal and you feel comfortable using the tools like Cargo for the build system and how to set up a project and how to pull in dependencies like libraries or crates, as they're called in Rust. It's definitely worth spending a couple days first, because I think it'll make your embedded experience go smoother. So definitely start with, let me link these for general Rust. You get the Rust programming language. There's stuff like Rustlings. There's also Rust by example. And these are all general resources that I'd recommend. Some of these are official, some of them are community driven, but I've heard really good things about all of these, and I've used some of these as well when I was starting to learn Rust. So I definitely have good things to say about them. When you're excuse me, when you're getting started with Rust embedded, I definitely recommend checking our book out. So we have our version of the book for embedded systems. This is actually our landing page where we have a couple things. I probably already have this open in a tab, but we've got the book, which is I know Rust, I know embedded. There's the discovery book, which is discovery is I know Rust, learn embedded. So it doesn't assume that you know like what a register is or a peripheral or anything like that. So it teaches you these kind of step by step, and how embedded development is different than desktop development. Just because you're not running on an operating system, you have some different design constraints there. We also have the Embededonomicon, which is deep concepts. This is stuff that you need when you're trying to write like more very close to the hardware kind of abstractions, where you're trying to make safe abstractions over unsafe code for hardware and things like that. It's worth a read. You probably won't need it when you're using applications, but generally I'd suggest starting with some of the Rust resources, then start with, depending on where you are right now, either the book or the discovery guide. And then when you're starting to build like deeper libraries and things like that, So these will prepare you to write applications using other people's libraries. And the embedded Nomicon can help if you are writing some really writing libraries and things like that that are very specific to the embedded ecosystem. So those are my general suggestions for learning resources for beginners. Hopefully that answers your question, Ari. Excuse me. Arturo is asking, is it possible to have a cargo workspace project with multiple targets configured, producing output for embedded and not embedded targets at the same time? I will say that I'm not sure actually off the top of my head. Typically you can have them in the same workspace. What you'd probably end up doing is having a .cargo config at each independent level. I'm not sure I typically do that in my workflow, just because with workspaces, at least personally, I don't use workspaces a lot. Workspaces have a lot of benefits of like having one build folder where you have shared artifacts and things like that. They can help with like making settings for the entire workspace if you know you're going to have consistent settings. But if you have different targets, some of these are less valuable in my opinion because you're not sharing, you're compiling for different targets, so you're not going to be sharing resources and things like that. I will be very honest, in a lot of my projects I just have separate folders, but that's my workflow. So the question is, do they is there a way to do it? There probably is, like, and then probably use something like cargo build all. Let's just go, caps lock, CD personal. So let me just copy, let's make their stream 2 3 stream 3. So let's try it out. I'm gonna copy one of my stream to, what do I have? Let's take my tiny NRF52. This is just some example that I was working on. So let's also pull up an editor for this. Okay, so in this folder, I have tiny NRF52, which is kind of a CD tiny. So just to show, I was doing something for the real prof. Git checkout master, and it's probably okay. I probably have some like build output here. Yeah, that's fine. So I can just do like a cargo build here. Oh, my computer's going to be sad because it does not like streaming and compiling code at the same time. I'm running on my laptop, not a very beefy machine. So sorry if it gets a little laggy here. Usually the audio holds out okay. Can I CD personal, and then let's go to the stream 3, and then let's do like a cargo new bin hello. So now I also have like a hello world desktop project in here. So let's just go hello stream. So if I go into my hello package, cargo build, so I can do cargo run, and then let's also set up a workspace. A workspace is also something that I always need to go look, but luckily I have the, I should have the, excuse me. Nope. Cargo workspace manifest. I never remember what goes into a workspace because I never use it. Workspace, path to the workspace. Oh, this is going to be workspaces chapter. Luckily, the Rust documentation is wonderful, and it's it's pretty easy to go find things. Okay, so yeah, it's just workspace and members. Members was the key that I was looking for. So I can, to make a workspace just at this top level, I would nano cargo.toml, because this is going to make me a workspace, and then I'm going to put this here, and then I can go look. So now it's a workspace, and don't need this one, so let's get rid of this. But I've got two members. I've got hello, and I've got tiny nrf52. So in my tiny nrf52, the way that I can just press cargo build is I've got this .cargo config up here, and this says that the target is thumb v7. So this was for an nrf52. So the target description for that is thumb v7 em nani abhf. So now that I've done this, I wonder if I just do a cargo build all. Warning profiles for the non. Okay, I have some optimization profiles set for that. So it does appear to be working. And apparently people are saying the YouTube quality is way better than Zoom. So I don't know what's up with that. If you're having quality problems with Zoom, maybe watch on YouTube. I am keeping an eye on the chat there. Yeah, let me know what you think. Oops, because I moved the build to here, it's moved the target directory. So it's going to build everything from scratch all over again. But we'll basically just see if we get a binary out from this. And if we do, then the answer is yes, and you absolutely can. Oh yeah, the real prof. Yeah, I was talking to you. On the tiny nrf52 repo, I was trying to reproduce some panic size problem that you saw. Yeah. Ooh, people are saying that they couldn't even read the big font over here. That's not good, but I think the quality is good on YouTube from what I've heard. So yeah, maybe go check that out. Language item required but not found. EH personality. Yeah, I think this is where it's going to start running into problems. So in Cargo Toml, we end up setting a couple things like panic abort. So I wonder if I can do. There's some fancy flags for like setting profiles for specific targets. The problem is I wouldn't want to set all of these options for my desktop profiles. I think there's some kind of syntax where you can do like, I don't remember what it is, like target equals thumb. Yeah, the answer is probably. I don't usually do it. I tend to just make two separate crates that live in the same folder, and I tend not to use workspaces. The benefit from workspaces typically is when you have a bunch of projects that you want to configure in exactly the same way. That's not to say you can't reuse libraries among there, but you probably wouldn't do it with a cargo workspace is going to be my answer. So sorry that was a little exploratory, but the answer is probably, but I also probably wouldn't recommend it. It's probably my answer for that. Hopefully that answers your question. Not embedded targets at the same time. Yeah. I'd probably end up having like a build command or something like that that just built them sequentially, or use another tool. Like I use cargo make a bunch, or there's also the just tool, which is very simple for automating builds and things like that. But I'm not sure off the top of my head. There's probably a way, but because the configurations for these two different targets are so different, I probably wouldn't typically try and combine them all into one workspace. Yeah, the real prof is saying you don't. Yeah, I don't put the .cargo config. The problem is if nothing else, I get a compile error because I didn't set panic abort is the problem. Okay, so Carlos Diaz is saying, just starting a project at work, or just working on a project that uses FATFS. Is there any FATFS support or any other FS port for embedded Rust? Should be a nice project to port it. Let's go look at the awesome embedded Rust list, because people keep that pretty up to date. I think there's a FATFS port, and I think there's actually even a pure Rust FATFS port, because I think the JP worked on that. FATFS. Okay, so I know there's embedded SDMC, which does give you FAT16 or FAT32 port support. Also with that, this is the one there. The other one that I know is there is a Rust. I'm surprised it's not on here. But we can go to crates.io. The other one that I've seen used is little fs2, where these two crates are aiming to be bindings to the C implementation of little fs. So little fs is another file system that's optimized for flash storage for microcontrollers. And I know folks who are using this in production right now. So I think there are some rough edges still, but I know it works enough for what they're using it for. So little fs2 is probably the most mature file system driver out there right now. Otherwise, I would take a look at what the embedded SDMMC crate is doing and see if there's enough FAT16 or FAT32 support in there for what you need. But it should definitely be possible. And I've also heard some people who are looking to re-implement LittleFS in Rust so that you don't have to bind to a C library. It just makes building a little easier sometimes. So definitely ping out on like the embedded matrix room if you're interested in that. And I know there's some other folks who are interested in that as well. They just haven't had anyone to work on it yet. But if you're looking to pick up a project and that's the kind of thing that interests you, I think you'll probably be able to find some people who are willing to support you and assist with that. I think no one's just picked it up off the top of their head yet, top of my head yet. Shearshock is asking, by the way, I heard there are some upstream issue with Rust on embedded. Is this true? Nope, not as far, like it depends on what platform you're talking about, but like embedded Rust has been a stable part of Rust since the 2018 edition, specifically the 1.32 version, which is like mid to late 2018. Since then we've been working totally happily. So I'm not sure what you're referring to. If you have a specific question or an issue, feel free to point me out and I can look at it. But in general, no, embedded's working really well with Rust for the last couple of years. Someone likes my Cowsay. Yeah, I've got my Fortune Cowsay prompt on there. Right now I'm doing an AVR Rust project. Sometimes when I want to do float multiplication and division, the compiler gives undefined reference to with a bunch of symbols. Do you think it might be an F32, F64 problem? Although I'm pretty sure all the variables I'm using are F32. Do you have experience with dealing with F32, F64 problems on embedded Rust? On regular multiplication and division, no. That sounds like maybe the AVR Rust project is having trouble with so if you're on a target that doesn't support hardware floating point, those are typically implemented by LLVM on some low-level fillers for doing F32s or F64 or floating point soft float operations. So typically Rust calls out to the LLVM intrinsics for that, and LLVM provides, if there's hardware support, it will just plug in the code for hardware for that. Polyfill is the wrong word. That's the web term, but there's intrinsics or something like that. That sounds like maybe AVR Rust hasn't implemented those and they might be missing. So maybe open an issue with the AVR Rust project. I know certainly on STM F0, which is a platform which doesn't have hardware floating point, I can definitely do multiplications and divisions. So that sounds like it's maybe a problem with the AVR Rust port where they may not have implemented that part of LLVM yet. I also know software floating point is challenging. So they may not have implemented that yet, but I would suggest opening an issue on the AVR Rust issue. Feel free to tag me if you'd like. I can point some more people in that direction. But that sounds like maybe something isn't implemented on the LVM port of AVR. So hopefully that answers your question, Rio. Boop, boop, boop. Yeah, some people in chat are pointing out embedded SDMC, MMC, which, yeah, I've pointed out. See, are there any other YouTube questions that I've missed? Okay, I think I'm caught up on the YouTube questions. Let me go check on Twitter and see if there are any Twitter questions. Don't forget you can do Ask Rust Experts on Twitter. You can talk to me on YouTube. You can talk to me on Zoom. No new Twitter one. So let me come back around. Actually, you know what I'm gonna do now is I'm going to plug Rust Experts again. So I have a company called Ferrous Systems where I work with some really great folks. Ferrous Systems generally does consulting and advice and development for all kinds of Rust problems, including embedded Rust problems. Let me systems.com. We also do a lot of training. So this is our website. Come check it out. If you are looking for assistant in Rust in basically any capacity, come talk to us. We'd love to talk to you. We also offer a service called Rust Experts, which is meant for people who don't need like a full-time consultant. They just need a little help. Maybe their teams are starting with Rust, and some people just get stuck sometimes, and they just want to be able to ask a question, and instead of like a forum where you can ask the question, you don't know if it'll get answered. We'll guarantee that we'll definitely answer your questions. And if we don't know the answer, we'll help you look up the answer. Sort of like this, but instead of kind of 1 hour or 2 hours on chat, you have continuous access to us. And we've got a bunch of people at Ferrous who are here to help out with a bunch of different areas. We've got some embedded folks, some IDE folks, some async folks, all kind of over the place. So if you're interested in that and you're looking for support, we've got a sale for until the end of April. You can get a 2-week trial of it for 64 euros. If you're a company, feel free to reach out. We'll talk to you about pricing. But for individuals, we're typically 500 euros a month. Or right now, like I said, we've got that special trial. So feel free to check that out. And yeah, like I said, we're here to answer questions like this that might take a long time to research, or you're not sure, or you need a little bit of advice on things, where we're able to kind of just jump in and answer the question for you very quickly and get you unstuck as soon as possible. So definitely check us out. We're Ferrous Systems. We run Rust Experts. If you would like some help or want to try out what it's like to have on-call support for Rust development, let us know. Yeah, that's my plug for right now. Okay, cool. So let me get back to answering questions. All right. So Nablegrow had a question, and I've been ignoring it for a little bit, unfortunately, but I will come back to it. So specifically asking for a project, simple working example, OLED and a display, just due to the fact that STM-F0 requires the peripherals to be defined within the critical section. If I want to use interrupts, this will all fail. Either the interrupts won't fire if I keep the existing loop or move the loop outside. My code won't be able to access the delay and display. I agree. Woo, that is a big, specific question. Let's see if I can pull something out of this. Otherwise, probably Nablegrow, my answer is going to be come talk to us in chat, because this is probably a bigger... So what's the problem? So STM32 sometimes requires you to set things up in a critical section, because things like changing timer configurations can really mess with some peripherals. So typically it makes you use a critical section for that. Interrupts fire if I keep the existing loop. I think what you're probably missing, Nablegrow, is you absolutely can... So you'll probably have 2 steps. You'll probably want to do your configuration in the critical section, and then you'll actually want to return your components out of that. So the critical section, this Cortex-M interrupt free, can also return items. Let me pull up my Otterpill repo, because I actually do exactly this. Otterpill Rust. Otterpill is this really cool little STM32F072 board. I've been having a blast playing with it in Rust. It's made by this this guy on Twitter that I follow who makes custom hardware, and yeah, it's just this awesome little USB-C STM board that does, like, it's awesome for making little USB gadgets. It also has USB-C power delivery on it. So for some reason you had a project where you wanted to pump 20 volts in from a USB port, you can totally do that. But I think I have exactly the answer you need, Nablegrow, because I do this. So I have this where I have my configuration section, and I probably could structure this better. This was just kind of like, oh, I started with 1 thing that became 2 that became 7, so I should probably refactor this code. where I do all of my critical section important setup inside of this closure. So this is a closure that has a critical section for the scope of this code. So I do all of my configuration there, but at the end, you can return all of the things that you set up inside of that. And that way, outside of the critical section, you can get on with your life and do the rest of the things that you need to do. It seems like this is what you need. If this is not, feel free to ask me another question, ping me on Twitter, Matrix, something like that. But I think you need to break up your initialization section and your operation section. And once you do that, I think you're going to be able to do the things that you want. And the trick here is that this critical section closure can return anything. So you can return all the peripherals that you want to return. I think that's what you need, and it should hopefully answer your question. If not, let me know. So Hazel UTF-8 is saying, the last time I looked at Rust low-level phi libraries, libpnet seemed to be the only thing related to low-level networking. Is there anything embedded that is like embedded HAL for wireless or wired phi interfaces? So for network stacks, there's definitely, I'll plug this. I know this wasn't your question, but it's such a cool thing. I want to show it off. So for networking stacks, there's this wonderful stack called small TCP. If, excuse me, if you've used something like LWIP or LWIP in C or C++, small TCP is kind of like a Rust version of LWIP. I'm sure the authors of small TCP will be upset if I said that, but it's a networking stack that doesn't require an operating system, which is perfect for embedded systems. I know people who are using small TCP for a bunch of stuff. Whether there is a low-level phi abstraction layer, I don't know. I haven't seen one. I think it definitely makes sense to have one. I've seen some individual drivers for phis. Let me go look at the awesome embedded Rust list again. Embedded Rust. I know in terms of things, I think the real JPster was talking about building something like this. Excuse me, because they use some, let's see, what if I type phi, physical computing? Nope. PNet. Yeah, I don't know. There may not be anything. There's certainly people who are using this. So like there's the small TCP STM32. I know there are definitely folks who are using small TCP with Ethernet, but I think the STM32F might have a built-in Ethernet MAC already. Like I think the hardware may actually have like a fairly oh yeah, they're writing the driver for the phi, so they actually are writing the phi driver. But this is like what you're saying, you're asking for something that's portable rather than is specific. So the nice thing about small TCP is it plugs in fairly well. It doesn't necessarily need to know about the phi. I think you just have to give it frames or buffers that contain frames or something like that. But yeah, I don't know off the top of my head if there's certainly not like an embedded HAL for phis. But if you're interested in that and you're looking for help on how to build one of those, definitely talk out in the Matrix room, because there's some folks like the JPster who is interested in a more generic, what did he call it? I think he called it something like embedded now. It's going to be gross JPster. I have to go find this. Network abstraction layer. I'm not gonna be able to find it. Hey, anyone in Matrix, if you know JP's embedded now, slash the JPster. He's got 2 GitHubs, so I need to go find JP stuff is also awesome. Oh, people are also pointing out there's the Ank 28J60 crate. So there's one for, yeah, let me pull that up because that one's good too. Again, this is not portable. This is people who have done it for a specific platform. So this is a portable driver. So it works on any platform that supports SPI, and it works with the ENC 28J60 Ethernet controller, which I don't think is is it a PHY or is it like a full contained? Yeah, it's got a Mac and a PHY, so it's basically like a SPI interface that you use to control a Mac and PHY. So I know these are super common in hobbyist projects and things like that. So there are crates for that. I want to say he had a. I'm just gonna go looking. JP is awesome. He does some really cool stuff. You should look up his talks for the Neo. I was right. It's embedded now. It's just not very searchable. Yeah, the idea was to have an abstraction layer that could be implemented by TCP/IP stacks, where it's abstract over like an AT modem or using small TCP. So I think this is actually maybe even one layer higher, where this is just meant to be an abstraction layer of I've got some data that I want to send over a network. So this might actually be in the opposite direction of what you're looking for, but you might be able to talk to the JPster, Adam Gregg um, on Matrix is probably a great person to talk because he's done a lot of stuff with Ethernet. Astro, basically look whoever's been working on small TCP and building projects of on top of small TCP, and they're probably good people to talk to. I do a lot of like packet-based radios usually, things like 802.15.4s and things like that. So I don't typically need exactly this, but yeah. Yeah, Dale's found it before I did. So the answer is there's probably some building blocks around that. I'm not sure if anyone's tried to build exactly that, but I think it'd be pretty cool to have a PHY abstraction layer. So unfortunately, I don't have a super compelling answer for you, Hazel, but hopefully that's helpful in understanding what the building blocks that do exist out there are. And yeah, let me know if you do find something and you're not quite sure if that's what you were looking for. Let me also plug one of just honestly my favorite resources is we have a Matrix room. So Matrix is a chat server, or I guess the Matrix protocol running on matrix.org. But there are some wonderful, I probably shouldn't actually pull this up. I should probably pull up what is the link? Matrix.to. I know what I can roll up. Let's talk about good resources. So another good place to find, so the Awesome Embedded Rust has links to a lot of this. This is also our coordination repository for the Rust Embedded Working Group. So I'm a member of the Rust Embedded Working Group. And there's this is what I was looking for. So there's a link here, join the discussion on Matrix. That will take you to our Matrix chat. There are an awesome number of people, and we usually have like a ton of people active at all hours of the day because we've got people in the US and Europe and Asia and things like that. So there's always a really cool discussion going on there. And if you're like, hey, who's doing this? That's another awesome place to reach out to folks in the community. It's probably the most active embedded Rust community meeting place that I know of. Yeah, definitely check it out. If you're interested, join it, lurk in the chat room, ask some questions. People there are pretty awesome. So definitely check it out. There's also links to other resources and things like that here, and you can find out like who are on the embedded Rust teams and things like that. This is wearing my embedded Rust hat, or my embedded Rust working group hat rather than my Ferrous Systems company hat. But yeah, there's a lot of stuff to find here. And in the worst case, open an issue if you're like, hey, is anyone working on this? If nothing else, I'll help you find them. I'll probably close the issue or point you in directions. But we also have meetings every Tuesday at 8 p.m. Berlin time. Right now, that's Central European summertime. But yeah, that's a good place to, well, not general chat, but a lot of people will be online and talking about stuff there. So if you're interested in following along in the discussions there, that's a good thing to do. Okay, I am currently out of questions. So I will take this as an excuse to take another 3-minute break, stand up, probably cough because I got a bit of a talking for an hour and a half straight has worn out my voice a little bit. So I'm going to stand up, drink some water, stretch, and I'll be back in 3 or 4 minutes. All right. Thanks everyone for watching. Don't forget to ask more questions on Twitter, ask more questions on YouTube, ask questions on Zoom so that I have something to talk about. Because otherwise, I'm just going to start randomly ranting about things for half an hour. And I don't think that's good for anyone. So I'll be back in a minute. And yeah, let me know what your questions are. Okay, I'm back. We had some more questions in boop boop boop. No questions in Zoom. I think people are slowly starting to move over to YouTube. Maybe next time I'll just do YouTube because I'm not sure. Maybe I'll just try YouTube next time because I think Zoom might be having some problems with bandwidth right now. But they're still serving it to YouTube at high quality, so that's good. I'm not muted. Good. Okay. Someone asked me, do I plan to make more Rust embedded stickers? So I've got I want to do this and try to knock over my water glass, but stop share. I've got on the back of my laptop, I've got some I'm plugged into like 5 different things, but I've got some Rust embedded stickers. This is the big one. I have a smaller one. It used to be on my phone, but I got a new case, so I don't have that anymore. Let me share my screen again. This one failed. No. Share. Am I gonna make more? Probably at some point. I don't know when. We don't really sell them. The nice thing though is, so I took the Rust embedded logo, which is CC by SA, and the stickers that I did make, I just tweaked it. I'm terrible at Photoshop, so we're gonna see it, but there is the Rust community resources where people have posted designs for stickers that you can go and have printed yourself. You can use services like, I'm not affiliated with any services. In the past, I've used Diginate in the EU, and I've used Sticker Mule, I think, in the US. It's been a while since I've printed stickers in the US. But in here, like if you go into resources, sticker projects, Rust embedded. Ooh, what's the Rustation one? Oh, okay. This is huge, but you can kind of see, and you can see my terrible ability to do photoshopping meant that I didn't even Photoshop it that well. But yeah, you can use these. This is the version I think I did that had the cutouts in it, because some services want like a cutout, so I think they're contoured or something like that. So yeah, if you want to make your own, you can use these, or like I did, you can start with the much higher quality logo that's in the Rust embedded working group repo, and you can submit that to like somewhere that builds. So yeah, I mean, here I think it's in assets. This is all CC by SA. So so you need to attribute. So if you build it, yeah, I don't know how attribute. It's not non-commercial, so you can probably sell them if you want. But all the stuff's in here. This is what I did. We got some transparent ones. I tweaked the pins so that they looked better on a black background. But yeah, otherwise, I'll probably, the next time I make a big batch of them, I'll send things out. Last time I just sent them out to people who shared cool projects and stuff like that. So maybe I'll do a giveaway like that sometime soon. So that was easy. Dutch Ghost. So this is an easy answer, but it's not a good answer. So how important is reference raw const for the embedded working group? I admit that I've seen that before, but I haven't followed it. So my answer is Rust raw. This is like no, this is. So Rust typically has had references and pointers, where references have a lot of guarantees about consistency and how you use them, and like the safety guarantees that come with them, and pointers, which is none of that. But the problem is there's like a really big gap between pointers and references, either mutable or non-mutable references. And there's been some discussion lately about having raw references, which are somewhere in the middle, where you get some of the guarantees of references, but not all of them. And that makes it easier to do things like FFI and some other items. I will admit that I haven't followed that super closely. So unfortunately, my answer is I don't know. They've certainly been mentioned in an embedded context, and I've had some conversations with people who are working on it. But off the top of my head, I unfortunately don't know. So they're likely to be useful to us, particularly with all of the memory mapped things that we do. I know there's been some issues with like providing references to memory mapped peripherals and things like that, because there's some impedance mismatch there of the guarantees Rust provides, or what LLVM is allowed to do with references versus what you actually want to be doing with memory mapped IO. But also it'd be really painful to always use raw pointers for all of that. So my answer is I'm not totally sure. It will probably be relevant, but I haven't caught up on that discussion yet. So unfortunately, I'd have to do some research, and I don't think I'm going to be able to do that. If we run out of time, or if I run out of questions, then I'll go and research that a little bit together with you. But I'd have to do some research to refresh myself. It's probably been a couple months since I've talked about raw references before. So sorry about that, Dutch. Yeah. Jason is asking, what tools exist in the Rust embedded ecosystem for understanding how big my final binary is going to be and how to optimize for code size? So there are two main tools, and it's funny, this tinynrf repo is actually entirely about that. Let me pull up here. So the first trick is usually, like, you probably saw this. So I'm gonna explain all the stuff in here, and or at least some of the stuff. So Rust does give you some tunables for how you want your your binary to be compiled, and this is not specific to embedded. We run into it a lot more often in embedded because we tend to need to tweak things more often. But there are these profile sections in your cargo toml that let you tweak compilation profiles. And the dev profile is if you just do cargo build, which is a debug or development binary, which is not optimized typically. And then there's the release. So if you type cargo build dash dash release, this will do a release build. There are a couple tricks you can do to help improve the performance and the size or the performance of your binary. Often at some trade-off, like your compilation might take a little longer, but most embedded projects are not so huge. So it can be the difference between, like, 1 minute clean build and a 1 minute and 10-second clean build, or sometimes even less. So a big one is link time optimization. This says at the final stage, at linking time, do one more pass and see if there's anything that you can optimize, not just looking at little parts of the program, but like the whole program. Like find sections that are the same and squish them together, or sections where like code is only used once. So instead of making it a function, just shove it in line and things like that. LTO is super useful. I would recommend it. Panic abort is something that most embedded projects have. Rust has some concept of unwinding panics, which has some performance overhead. In embedded, most of the time when you're panicking, you're saying, show's over, I need to reboot, or I need to lock up, or something like that. So panic abort helps for that. Debug, interestingly enough, you do want to always keep on, because for flashing an embedded systems binary, the debug info is not put on your actual microcontroller. It only lives on the firmware image on your desktop. So you want to keep debugging on because it will help your debugger pick up those symbols. Unlike when you're doing that for a program for a desktop where like all that debug information is in the binary. So like it's still in the elf file, but the difference is for a microcontroller, you just pull out the executable code and put that on the microcontroller. You don't actually copy the embedded stuff there. Someone's pointing out that there's multiple options to LTO. True is an alias for fat. So there's actually a couple different versions. You can also go into that cargo manifest specification and it explains all the different options for this. I just want to explain the ones that I typically use. But yeah, I usually use LTO true, which is saying do a full LTO, even if it's slower. Incremental is false. Rust has some cool features to do incremental compilation where if you only change parts of your code, it doesn't recompile, like it recompiles smaller chunks. But the problem is sometimes that can it can compile way faster, but sometimes it produces slightly like 10% larger binaries, which is not a big deal on a desktop, but can be on an embedded system. So I almost always turn off incremental. Code gen units 1, again, it changes how the compiler works and how it like breaks stuff up for parallelization, where code gen units 1 tends to like not parallelize things as aggressively, which means that your compilation probably takes a little longer, but because everything's done in one place, it has a better chance of optimizing. The difference here, so the settings are actually all the same. Rust has opt level, where if you come from like C or C++, if you've seen like .os or -03 or -01. Rust uses a very similar syntax for this. The options for opt level are typically 0, 1, 2, 3, S, or Z. Where these are different levels where they're just kind of increasing, turning the optimization knob up. S means specifically optimize for size. Z means optimize for size, but if there's some really good optimizations that might increase the size, still do those. I think it's S, but it's tweaked inlining and vectorization thresholds, if I remember correctly. But yeah. So these are all tricks for making your binary smaller, for observing what they are. So Rust, because it's based on LLVM, it still works with regular bin utils. So I did a build here. So if I wanted to see like, if I just do an ls target release, I guess I built this some other time, ls target thumb is actually what I want, release. So I have this binary called tiny nrf. So this is my actual application. So let me full screen this and make this, well, maybe not full screen, but let's make the font much bigger. So if I want to get the information on this, so you see my actual binary, and the actual binary is 348 kilobytes, which seems like it's really, really big. And that's, you're like, that will never fit on my microcontroller. Like I said, that's all of the like debug info and everything is in there. What actually makes it onto your microcontroller, you can see with arm, none, IABI size. I use AX usually, or let's just do A for, or let's just do arm none IABI size for the same file. Thumb, release, tiny. So again, this is exactly the same file. This actually shows you what your size is. So actually my program size is only 4.8 kilobytes. And I use 4 bytes of static RAM. So this is like global constants basically. So you can use arm none IABI size. Another tool that's super, so use arm none IABI size because that's the only thing that's going to give you accurate information of how big the parts of your binary. Like when you're trying to answer the question is, will this fit on the flash on my microcontroller? You want to use arm none IABI size. There's also, I think, bin utils. So I think there's Rust. Does cargo size work? There's some tool that you can use there that's built in that uses LLVM instead of GCC, so you don't have to install the GCC toolchain, but I don't remember the command for that off the top of my head. Another useful add-on is called cargo bloat. So if I do cargo bloat release, RMRF, let's get rid of that workspace because I don't want that anymore. So cargo bloat is a tool that's useful for embedded as well as desktop programs. It's basically a plugin that breaks things down by crates or by sections, so you can get like a rough estimate of how much of your code comes from which crate. Actually, let me. I also recently wrote a blog post that goes over some of this. Let's see if I can Google my own blog post. Where I'm generally talking about, so one particular problem where you actually get unexpected large amounts of code is when you do formatting or use panics and things like that. And that's a longer conversation than I have time for today, but maybe read this blog post and I go over why and what happens, but I also go over some things that I can do to tweak that. When I'm talking about cargo bloat, this is the output you get. You get kind of like a per function layout of each of this. So like this is the output of arm none IABI size, and this is the output of cargo bloat. So you can kind of see cargo bloat's not 100% accurate because it's kind of making guesses on where these functions come from, and particularly after optimization, stuff gets inlined and optimized. So like code size shows up in weird places after it's been optimized, but you can kind of see where it is here. But this blog post, this is on my blog. I talk about a bunch of like different things that have different impacts. So like I make some really small tweaks, and in some cases I'm able to get the firmware down to 1 kilobyte. For most cases, I'm able to keep it around 4 or 5 kilobytes. And then if I accidentally trip over some things and I pull in formatting, it gets up to 14 kilobytes. Like I said, I go around some workarounds. People have already started implementing some of the changes that I proposed in this. So this is getting better even from when I wrote this blog in December. And that's part of why I wrote the blog, is to draw attention to this. But improvements are happening. And if you're running over some problems where it's bigger than expected, file an issue and we'll help track that. And that's kind of our job as the embedded working group, is to chase down some of these things. So check out this blog post. I go over some of this stuff. Hopefully that answers your question. Someone's asking about read volatile and write volatile. So an interesting difference in Rust and C. In C, you mark data as volatile. So this variable or this like static variable will be volatile. In Rust, access is volatile or not. So you can't just say like this variable X is volatile. Instead, you would do a volatile read of the X variable. You do always need that with memory mapped IO. You don't see that a lot of the time in embedded systems libraries because we have abstractions that build on top of that. The peripheral access crates generate code that does this for you automatically. When you use, there's also a library called, I can never remember what it's called. It's called volatile cell or vcell or something like that, where that's how we have abstractions over that. So you rarely see that in application code because we typically are building over abstractions over that already. So that's why you don't see it like front and center all the time. You do need it anytime that you are, like in the same case you would need it in C where you would need a volatile. But instead you're going to be using the pointer read volatile or write volatile methods. So you don't see it because we hide it because it's an abstractable detail, but you do need it if you are like just manually reading from some memory map peripheral or something like that. I'm also going to turn my lamp on because sun's starting to come down here. Is there any effective code gen when LTO is turned on? Yeah, it's doing separate LTO, or it's doing separate optimization passes. So it can definitely change what your resulting binary looks like. Usually that's smaller and faster most of the time, but you do want to check. I would treat it as it's my default setting, but it's just a tool in the toolbox. So you should always, like, if you're really optimizing the last bytes out of something, you should definitely check. Sometimes even like opt level 3 can produce smaller binaries than opt level S because it just makes a bunch of aggressive optimizations. And by the time that it's done like multiple levels of aggressive optimizations, it was able to smush it down even smaller than the optimizations that are designed for size. So if you really are squeezing the last bytes out of your firmware image, you've got to play around with it because there's no like optimizers are all heuristics based. So there's no like one right answer for everything, but it's good to know all the like dials that you can choose. And yeah. Some people are asking about what's the status of the GCC front end. It would make the program very portable. There's been a couple attempts to make Rust code compiled down into C code so that you can leverage other compilers. The two projects that I'm aware of are mrustc, which is a C++ implementation of the Rust language that compiles down to, I think it compiles down to C code. Maybe it compiles down to LLVM still. I'm not sure. Or there's LLVM-CBE for C backend, which makes LLVM generate C code instead of native code. Both of them are very experimental. They're useful in some situations, but they're not generally like globally useful, and they have some limitations. Like mrustc, I know people have used it to compile stuff for the ESP32 family, but the problem is it doesn't support the borrow checker. So you don't get all of the features of Rust. So you still need to kind of check it there. So there's some useful experiments going on, but there's no like globally available C compiler there. Yeah, someone also pointed out that, yeah, you need volatile reads because it prevents reordering, stuff like that. Yeah, so definitely, if you're not super familiar why you would use volatile in C, um, well, if you are familiar, you're going to need it for the same things in Rust. If you're not familiar, we've got some teaching materials in the Embedded Nomicon, I think, that talk about this. Yeah. Bup, bup, bup. Yeah, MRC compiles to C. Okay, yeah, I am remembering that correctly. Yeah. And there's some people commenting on the AVR Arduino crate. If they're just or equaling the register ports, that sounds not right. Like you can do that, but it has potential to break. So Rio's talking about the AVR Arduino crate is just doing or equals instead of like a volatile read and a volatile write. That's the problem with undefined behavior is, well, it's not exactly undefined behavior, but like the optimizer can decide to do different things. The volatile stuff is the only way to guarantee that the compiler will do it right. When will this be available as a recording? Probably like an hour after the stream ends. Well, I'll just hit the publish button and it'll be live. We don't typically do any editing on this. Okay, last call. We got 5 minutes. I've been trying to answer a bunch of questions very quickly. So if you've been holding on to a question, if you have a quick one, shoot it to me. I've got about 5 minutes left and then I'm going to go. I go on vacation tomorrow. So this is kind of the last thing that I'm doing before I go on vacation. So I'm excited to wrap up, but I'm also super excited to see all the people who have been here answering questions, and hopefully it's been super helpful for you. But let's see if there's any last minute lightning questions. I do want to also mention, so someone way before people were talking about emulation, and I said I should come back and talk about no standard. So tying a couple things together, I do want to talk about this for a minute or two, and I'll keep an eye on the chat for people asking questions. The nice thing about Rust, like I said before, is that desktop Rust and embedded Rust are actually not so different. Unfortunately, or fortunately, Rust has broken up its capabilities into two main groups: works with the standard library and works without the standard library. The Rust standard library makes assumptions that you have an allocator, like you have heap memory and things like that. You have threads, you have sockets, you have files, you have all of these things. But Rust has been really, really good about, if what you're building doesn't require those things, it pushes all into the no standard category. No standard is kind of the Rust. I mean, it's the Rust setting that says you don't need a standard library. So almost all of this bare metal embedded stuff that we're doing works with the no standard library. And you can actually build some really powerful things that don't require the standard library, but you can use them just as conveniently on either side. So I've gone back to my Otterpill example a couple times, but this is like one of my favorite examples of stuff that you can do on embedded and desktop, where I have this project called Vintage, which is a little button pad that I use for time tracking. But it's got three parts. It's got the Vintage binary. So this is my embedded binary. Let me close all my other tabs because that'll be easier to keep track of. Ooh, 31 tabs. I'm bad at closing tabs. I usually just close windows after a while. So I've got three things. I've got Vintage, which is my firmware binary. I've got the Vintage CLI, which is my command line application on my computer that talks to my embedded binary. So this is connected, excuse me, over USB. And I've got Vintage ICD, which stands for, it's my habit of working in the avionics industry. It's interface control document, which is just like all of my serialization types. But in Rust, there's this really cool library called Serde, which is a jack of all trades serialization and deserialization framework, where you can make it work with like JSON and TOML and YAML and even binary formats and stuff like that. And most of these require the standard library. Like JSON uses the heap to build strings, to build JSON stuff. So it requires the standard library. But I've built a library called Postcard, which implements Serde as like a framework for serializing and deserializing things. But my Postcard version doesn't require the standard library at all. So you can actually use all of the high-level serialization and deserialization tools that Serde provides, but you can use it on a microcontroller, and it builds a really, really small, packed binary serialization and deserialization format that you can use on microcontrollers or on desktops or wherever you would like. So I use Postcard on both my desktop CLI and on my microcontroller. So I have the ICD, all I have to do is define the types. So I just have all of the messages that can go from my host to my device or my device to my host. And I just define using Serde, serialize and deserialize. I say, hey, here's some Rust enums or here's some Rust structs. And hey, Serde, automatically figure out how to serialize and deserialize that. This is the stuff that's provided by Serde. And I can just say, like, instead of hand byte packing or bit packing all this stuff, I can just say, here's a Rust struct. And Serde goes, cool, I know how to serialize that. And then when I go over on my embedded side, I can just deserialize stuff. And I use Postcard's ability to serialize and deserialize stuff. And I can either receive it from the wire or I can send it out over the wire. So basically, like, I just have like one loop where it says, did I get any messages or do I have any pending messages to send out? This is like my entire USB control function that just happens every time there's a USB interrupt. So it just says, oh, is there data to go out or is there data to go in? And if so, I just serialize or deserialize. And then on my desktop side, I can do exactly the same thing, but in the other direction. I lost my CLI. Here it is. So I just have like a really simple little command line application. This is really ugly code because I hacked it together in like one night, but I do the same thing. I basically say, are there messages coming in or are there messages going out? But basically I can just think like I'm sending Rust structs, but I don't have to worry about the fact that one is 64-bit and one is 32-bit. I don't have to think about one's little endian or big endian. I don't have to worry about like stuff on the wire. And because Postcard is a no standard library, I can use it with the standard library or without, and it doesn't matter. And I can use it in both places. So like you can kind of think of it like a superset of things, but this is super powerful because you can do things like share code with your embedded system, like a WASM front end. You can have a server backend, an iOS app, and an Android app, and you can write one Rust library that works on all 5 of those platforms, and it just works seamlessly with each other. So this is like Rust being super powerful. And even if you're not talking about building on an emulator, you can still build things that work on embedded systems, but run on desktop systems when you're trying to test them or when you're using them in different environments. So I know I mentioned, like at the very beginning of the stream, I mentioned embedded graphics. Embedded graphics has a whole simulator that runs on the desktop that uses the same interfaces that are available to your microcontroller. And it does this so you can draw it in like a window on your desktop for testing. And then you can deploy that exact same code to your microcontroller, and it's going to work exactly the same with your real hardware. So that's not really emulation or simulation. It's just like portable code, which is super, super powerful. Okay, I kind of went on a 5-minute rant, but out of 2 hours, only going on a 5-minute rant is pretty good for me. So I'm going to make one last round. I know, Nabelgrau, you had some clarification. Come chat with us on Matrix. I think we can help you out. I'm going to give you a quick answer. You're probably looking for the shared bus crate. Shared bus is a handy a handy Rust library for sharing peripherals that need a mutex. The answer is you probably want the shared bus crate. If not, come talk to us in Matrix and we'll help you find the answer to that. But I think I have answered all the questions on YouTube. I think I have answered all the questions on Zoom, and we are just out of time. So thank you all again very much for sticking with me for 2 hours and listening to me talk. Thank you for answering questions. It was super good. Keep asking Ask Rust experts. If you are interested in things like development process and tooling and how to get more out of your editor, definitely come back at the same time next Wednesday, where Alexei Kladoff or Matt Clad from the Rust Analyzer project in Ferrous Systems is going to be doing the same thing for 2 hours. And yeah, definitely if you need some assistance, if you're like, oh, I'm excited and having this was super useful for me to get it unblocked, definitely check out Rust Experts. Reminder that we have a sale. This is going to be active until the end of April. You can start using it whenever, but you do have to purchase it before the end of April. for 64 euros for 2 weeks. We sell worldwide. Yeah, we'll put you in a chat with us. We will answer your questions on very short notice, and you'll get this kind of experience, but on your private questions and things like that. If you're a company and you want this for your whole team, ping us. We're very happy to provide. We've been helping some folks out with this, and they've been really enjoying it. No, Naval Grout. No, I guess wrong. So he'll have to come back for more help later. But yeah, definitely we've got our schedule up here. We're going to be adding more schedule for other folks talking about things. So keep an eye on this Rust experts page. Follow me on Twitter. I'm BitShiftMask. I yell about Rust and embedded all the time. Yeah. So I hope that was useful. Come check us out. Let me know if you have any questions. Reach out on email or whatever. I'll stop saying goodbye. Thank you all very much for watching. See you next week for the chat with Alexei, and have a great week, everyone.